Morning, everybody. We're going to finish up our last day of the section or of the unit today. So we're going to be looking at solving some more types of rational equations. With this being our last day, that means that we are going to have our review next Monday, and then we will have an exam on on rational expressions, equations, and whatnot on next Thursday. So the ones we're going to work with today are going to be a little bit, they're going to have a couple more layers to them. And what we're going to do is use the same thought process, use the same methods that we used last class, except there's going to be just a little bit more work involved. So we're still going to find the LCM. We're going to multiply by that LCM. And then we're going to use a little bit of algebra to simplify these things. So the first equation that we're going to look at is we're going to try to solve the equation 4x plus x divided by x plus 1 equals negative 1 over x plus 1. So real quick, before we get started with this problem, we need to acknowledge that we have a denominator and that denominator cannot equal 0. You cannot divide by 0. I'm going to harp on this over and over and over again. So the denominators we have is that x plus 1 cannot equal 0. So that means that x cannot be negative 1. So if that pops up, that is not something that we can use. So now we're going to find the LCM. So the least common multiple for these, this 4x has a denominator of 1. So we don't really need to include that. So really the only thing that we need to include is x plus 1. That's our least common denominator, LCD or LCM. So what we're going to multiply everything by here is by an x plus 1. Let me find my other color pen. Let's see. So we're going to multiply every numerator here times x plus 1. Oh, wrong numerator, x plus 1. Now, here, these are going to cancel, and that's just going to leave me with a negative 1. These x plus 1s are going to cancel and leaving me just with an x. X plus 1s can't cancel here, so we're just going to regularly distribute. So we're going to get 4x squared plus 4x plus x equals negative 1. And so now we've got to go and solve this equation. So let's combine these terms real quick. 4x squared plus 5x, and I'm going to bring this negative 1 over. I'm going to add 1 and set this equal to 0. Now, what we have here is we have a quadratic equation. So the two ways that we have learned to solve those in this class are that we can either use factoring, if that will work, or we can use the quadratic formula. So I'm going to see if this will factor real quick. So a times c, things that multiply to 4 and add to 5. We've got positive 4 and positive 1. Those are the numbers that will work. We're using those numbers to rewrite this b term right here, this 5x. Well, that's the same thing as 4x plus 1x plus 1. We've created these two groups. In this first group, what's common there? Let's see, there's a 4 and there is an x. So that's going to be what? X plus 1. And over here, we've got a 1 and an x plus 1. In those, we have an x plus 1 that's common, so we're going to factor that out. And then our other factor here is going to be 4x plus 1. So now we've just got to solve each of these. We're going to set each of these factors equal to 0. So x plus 1 equals 0. 4x plus 1 equals 0. Let's see. This is going to be x equals negative 1. And this is going to be 4x equals negative 1, which means x will equal negative 1/4. Now, remember, we said at the beginning of the problem, the value that won't work for x is going to be x equals negative 1. So this answer right here is extraneous. Even though it pops up, if we try to substitute that back in to our equation, it is not going to work. So you do need to be in the habit of listing out what x values are not going to work for your denominator and then checking to see if they'll work. So the only solution to this particular problem right here is -1/4. So let's take a look at another one of these. So here we've got the equation x divided by x plus 3 plus 8 equals 9 divided by x squared plus 3x. And we want to try and see if we can find a least common denominator here. Now for us to do that, this right here is going to make our life easier to find the least common denominator if you factor. So let's rewrite this as x over x plus 3 plus 8 equals 9 over, we can factor out an x out of both of these things, x times x plus 3, and we can now find our least common denominator. So both of these denominators have an x plus 3, so I'm going to include that, and that will take care of both of these. And then we also just need a regular x. So while we're here, let's also let's figure out what our denominator cannot be. So the denominators cannot be 0. So the things in our denominator, we're going to have an x. So x cannot be equal to 0. And also we're going to have an x plus 3. X plus 3 cannot equal 0. So then that means that x cannot be -3. So if when we solve this, we end up getting either of those answers, then we have to throw those out. We cannot have that as an answer. So now that we know that this is going to be our least common denominator, we need to look at each one of these things and say, okay, what does this need to get multiplied by to be our LCD? So, like for example, this denominator has an x plus 3. Well, it's missing an x. So I'm going to multiply this equation times x, or excuse me, this numerator rather. Oh, excuse me. We're going to multiply the entire thing by x times x plus 3. Mr. Price was getting his stuff mixed up real quick. We're going to multiply this right here, I'm a little low on room, times x over x plus 3. And we're going to multiply this right here times x plus 3 times x. So when we go to simplify this, on this term, these x plus 3's are going to cancel. We're just going to do x times x, which is going to give us x squared. Here we're going to do 8 times x, so that's going to be plus 8x times x plus 3. We'll simplify that in a second. Equals, these are going to cancel and give us 9. So let's see here. That's going to be 8x squared plus 24x equals 9. We've got x squared here. And if we go and we clean this up, let's see. Combine those two, that's going to give us 9x squared plus 24x. And I'm going to subtract this 9 over. So we've got an equation here again. It's a quadratic. We've got to see if it will factor or if we can use quadratic formula. So let's see. If I factor this, 9 times -9 is -81. B is 24 here. So things that multiply to 81 and add to 24. Those would be 27 and -3. So I'm going to rewrite this, 9x squared plus 24x minus 9. I'm going to run out of room here, I can just tell. 9x squared plus 27x minus 3x minus 9 equals 0. And let's factor this, let's solve this. So 27 and 9, we can take a 9x out of those, 9x. Let's see, x plus 3, -3x and -9. We can do a minus 3. Let's see, x plus 3. And so our factors here are going to be x plus 3 and 9x minus 3. And these are both equal to 0. So we need to set these equal to 0 real quick. So let's do that. So if we set x plus 3 equal to 0 and we set 9x minus 3 equal to 0, we're going to get that x equals negative 3. And then we're also going to get, let's see, add the 3 over, 9x equals 3 divided by 9, x equals 1/3. And so these are the two answers that we get from doing the algebra. So now we got to make sure we look. We said earlier, x cannot be 0. It can also not be negative 3. If we substitute in negative 3, you're going to get an answer that does not work. So this is extraneous. Even though it pops up, this is not an answer here. So we're going to rule it out, and our actual answer is going to be the x value of 1/3. And so these are pretty intricate problems. They are problems that take a little bit of thinking, but the thought process is the same for what we've been doing. It's the same thing that we've been doing, same that what we did last class. So we're going to look at 2 more of these, and then let's see if we can start getting the hang of this a little bit. So with this, the next one that we've got here, we've got the equation 1 plus 1 over x minus 1 equals 3 over x squared minus 3x plus 2. So the first thing that we're going to do is let's see if we can find a least common multiple, least common denominator here. And again, this is a trinomial. We need to see if we can factor this real quick. So let's see, things that multiply to 2 and add to negative 3. That would be negative 2 and negative 1. So I'm going to rewrite this. 1 plus 1 over x minus 1 equals 3 over x minus 1 times x minus 2. So our least common multiple, our least common denominator that we're going to have to multiply the entire equation by is we're going to need an x minus 1 from both of those things. And then we're going to need the x minus 2 from this denominator. So again, let's state what our denominator cannot be. So the denominator cannot be 0. So in our denominators, we've got an x minus 1. That cannot be 0. We've also got an x minus 2. That cannot be 0. So that if you just add those over, we get that x cannot be 1. X cannot be 2. And so now what we're going to do is multiply by this least common multiple. We're going to get rid of all of these denominators. X minus 1, x minus 2, and then I'm going to squeeze this in here, x minus 1, x minus 2. So right here, these are going to cancel out. The right side of this equation is just going to be a 3. These x minus 1s are going to cancel out. So we have 1 times x minus 2. That's just going to be an x minus 2. And on the left-hand side, we just have 1 times the LCM. Well, the LCM is actually just what this factored to. So we're going to call it, we know x minus 1 times x minus 2 is going to be that denominator. So I'm just going to write that in. X squared minus 3x plus 2. So let's clean this up a little bit. We've got x squared, let's see, minus 3x plus 2x. That's going to be minus x. Actually, that needs to be a... Mr. Price made a mistake here. That does not need to be a 2. That needs to be a plus x minus 2. So that's going to be, let's see here. Sorry about this, you all. I know what I did. Sorry, I just had a little bit of a brain fart here. So we're gonna have, sorry about this, you all. So we're gonna have x squared minus 3x plus 2 plus x minus 2 equals 3. And that's going to be the equation. Sorry, I wrote something down poorly. So we're going to have x squared minus 2x. These minus 2's will cancel. And then I'm going to bring that minus 3 over and set this equal to 0. So now what we're going to do is we're just going to factor this thing. This will be easy factoring for us. So things that multiply to negative 3 and add to negative 2, those are negative 3 and positive 1. So we are going to get, let's see here, x minus 3 times x plus 1. And this is equal to 0. So our answers for x here are going to be x equals 3, x equals negative 1. And here's the thing, since these do not go against the restrictions that we have, both of these solutions are going to work. Both of these solutions will, in fact, work. So what we're going to do is we're actually going to skip the fourth example right here because I want to get to the application of some of these equations with work rate problems. And I think if we've done 3 of these, I think we have got the large understanding of this. So we're going to forego this last problem here. If you do want to work it out and see if you got it correct, join Zoom and we can talk about it together. Otherwise, let's move on to some rate problems. So for these rate problems, we've got 2 people who work at different rates. So in this problem, we've got Arthur and we've got Cheyenne. So together, these 2 people can paint a wall in 6 hours when they're working together. Now, Cheyenne is a diligent worker. She can work twice as fast as Arthur can. And what we want to try and figure out is how long would it take Cheyenne to paint the wall if she were working alone? If she were working alone. So to set up a rate problem here, what we're going to do is we're going to write out everything that we know. So Arthur, we know his rate is 1 wall in some amount of time, in X hours. And what we know is in the same amount of time as it takes Arthur to do 1 wall, Cheyenne's rate is double. She could do 2 walls in X hours. And we know that together they can do 1 wall in 6 hours. So to figure out the rate, how much of a wall they get done in 1 hour, to get the rate, we're going to divide the wall, so 1 wall every 6 hours. And we're going to do the same thing to get these rates. So Arthur can do 1 wall every X hours. And Cheyenne can do 2 walls in X hours. So if Arthur and Cheyenne are working together on this wall, what we're going to do is we're going to add their rates together. We're going to do 1 over X plus 2 over X, and we're going to set this equal to 1 over 6. And this is the equation that's going to represent their rates here. So now what we have to do is we have to solve this equation. So let's see, we've got the LCM, we need 6, and we need an X. So we're going to multiply this entire thing by 6X. Now, again, the denominator cannot equal 0. So 6 obviously cannot equal 0. X cannot equal 0 because you can't paint a wall in 0 hours. That doesn't make sense for that to be a thing. That would just be you blink and not even you blink. It just all of a sudden gets painted. So what we're going to do is we're going to multiply this entire thing. We're going to say, okay, this numerator gets a times 6x. This gets a 6x. This gets a 6x. We're doing it equally. these x's cancel. 6 times 1 is 6. These x's cancel. 2 times 6 is 12. So 6 plus 12 equals, these 6's cancel, equals x. So we're going to get x equals 18. Now, here's the thing. We need to interpret this in context of the problem. So Arthur can do one wall in 18 hours. That's how long it's going to take him by himself. Cheyenne over here, since we were trying to find Cheyenne's rate, if she works twice as fast, she can do 2 walls in 18 hours. So Cheyenne can paint 1 wall in 9 hours. So that is the basis for a work rate problem. You want to try and list out your rates. If you're working together, you want to combine those rates and then see what it works out to be. So let's look at one more of those, and then we will call it a day. Last day of the unit. So here we've got a pool that we're filling up. So it takes 12 hours to fill a pool with 2 pipes. So the water in one pipe flows 3 times as fast as the other pipe. So one of these is really just leaking water. The other one's just spewing water. And we want to figure out how long would it take for the slower pipe to fill by itself. So let's see. We've got the slow pipe. We'll use SP. We'll use FP. And we'll use together. So together, we know that they can fill one pool in 12 hours. And so we're going to represent that using the fraction 1 pool every 12 hours. That's our rate there. The fast pipe here and the slow pipe here, we have to represent those. We don't know exactly how long it's going to take. So the slow pipe can do 1 pool in X hours. And we're going to represent that with the rate of 1 over X. And same thing for the fast pipe. It works 3 times as fast. So we're going to say it can do 3 pools in the same amount of time, in X hours. So when we write these, we're going to say, okay, well, we're combining the slow pipe plus the fast pipe, and that should equal 1 out of 12. So if we combine the rates of these, they should be able to do 1 pool in 12 hours. That's how you read this equation. So now what we're going to do is find the least common multiple, the least common denominator. Again, time cannot be 0, or the pool, time cannot be 0 here. So I'm not going to list that for this problem. The LCM here, we need a 12. We need an X, and so this is going to be what we multiply by for this equation. We're going to say 12x, and so really what we're doing is that's just going to be multiplying each numerator here. So 12x here times 1, 3 times 12x, 1 times 12x, and we can start canceling here. So these x's here will cancel. We'll get 12 plus these x's will cancel. 3 times 12 is going to be 36. Let's see, these 12s will cancel and we'll get x. And so we're going to get x equals 48. So since we are trying to find the rate of the slower pipe here, if x is 48, well, the slower pipe does 1 pool in 48 hours. So that is the rate of the slower pipe right there. The rate of the slower pipe. So that is all that I've got for today. If you have any questions on solving rational equations, or you've got to find more complex LCMs and do a little bit of factoring to solve, please let me know, and we can set a time aside to look at that together. Otherwise, I hope you all have a good rest of your week and a good weekend, and I will see you all on Monday. Bye.